All right, so what we've done so far is we've learned about conduction, radiation, and convection, correct? So if we're talking about those three things, conduction is where you actually touch something. Convection is where the heat rises and the cool air goes down. Radiation is what's coming out or around where we can touch it, right? And then it showed us calorimeter. So the next thing I had y'all do is I had you write down the temperature scales of conversion. Then I had you write down the formulas that we are going to be doing today. And so now what we're going to do is we are going to be on page 326. And we are going to do those two practice problems here, 1 and 2. Because remember, we don't do the challenging ones, do we? So the first one says, when you turn on a hot water of a water dish and the water pipe heats up, how much thermal energy is absorbed by copper water pipe with a mass of 2.3 kilograms when the temperature is raised 20 to 80 degrees? Okay. So we're trying to find Q, right? Q equals MC change in T, correct? So what do we have in this formula here? Okay, so that's our mass, right? Mass is 2.3 kilograms. Do we know what C is?
It says it's raised from 20 to 80.
Yeah, 20 to 80.
Celsius.
Okay, so that's my change in temperature, right? And you said it was what?
20 to 80.
20 to 80, okay. Degrees, and what degrees was it? Was Celsius? Or? All right. Is there anything else we have?
No.
How about C? C is a constant, right?
Yeah.
Okay. 385 joules. Where do I get that? I got that from this page before, specific heat of water. Do you see it? Okay. So, what does it tell us to do? You take your mass, 2.3 kilograms. You multiply by your specific heat of water, which is 385 joules. And then we're going to multiply that by the change in temperature. Well, 80 to subtract 20 is 60, right?
Yeah.
So this is 60 degrees Celsius. All right. Let's get our calculators out. And let's see what we got.
Don't say the answer.
I won't.
I just started putting it in. Don't you say it? I'm telling you.
And change that to scientific, please, instead of giving me a big number.
How you do that? Mole.
Yep, mode scientific.
What mole is it?
Second answer.
How you? What a mole is?
There's the mode's right here. Look. Right there. Mode. And change scientific. Move it over one. There you go, baby. And then do second answer if you've already done it.
No, I ain't did it before.
Yeah.
Okay, cool.
5.31364.
Correct.
I just told you not to say it.
So write it down, Jay. That's perfect. Okay?
Hold on.
I'm not saying anything, and you only heard him once, so I'm hoping we're holding up that you can do it. What'd you get, ma'am?
5.313E4.
Okay, so it'd be 5.3 times 10 to the fourth power, right? So write that down. 5.3 times 10 to the fourth power. That's our answer for question number 1.
5.3 times 10 to the what?
Fourth power.
And that's the answer.
That's our answer.
Okay.
All right, so let's look at the second one. The second one says the electric power company sells electric energy by kilowatts per hour, where 1 kilowatt per hour is 3.6 times 10 to the 6th joules. Suppose that it costs 15 kilowatts per hour to run the electric water heater. How much does it cost to heat 75 kilograms of water from 15 to 43 and fill the bathtub? Okay. So, let me erase these numbers, right? We're gonna be doing the same thing again, aren't we? All right, does it tell us the mass?
It says 1 kWh 1.6 times 6 Chicago. And the cost is
75 kilograms of water, right? So our mass is 75 kilograms, isn't it? Do you see where it's at the very end? So it's 75 kilograms. All right, what's my change in temperature?
15 to 43.
15 to 43. What's the difference in that? 43 minus 15.
28. 18 or 28.
I got. Hold on. Because I'm still in the scientific. Hold up.
What about cost to run the electric water?
You
Yeah, we're
said
almost there.
43 subtract what?
15.
He was right, 28.
Yo. All right. We're doing water again. What's our constant of water that we used last time?
35.
Okay. All right. So the first thing it asks us is it wants to know how much does it cost to heat 75 kilograms of water from that, right? And it's telling us it's 0.15. But the first thing we have to do is we have to find Q first, right? How much work? So how do we do that?
You do 75.
Yep.
Then you put the 385.
385, okay.
And then you put 28.
28. All right. Y'all tell me what the number is. Because this is going to tell us work, but then we're going to have to do something else to find out how much it's going to cost us.
You go back to scientific, right?
Yeah, you can stay there.
Okay. 70. I got 8.085 E5.
Yep. So it's 8.08 times 10 to the fifth. Now, what are we going to do with that number?
We're gonna multiply. Wait, no. We're gonna divide that by 3.6 times 10 to the fifth.
Yep. Okay. So what we're doing is we found out how much work was done, and now we know 1 kilowatt equals that much, right? So we're going to divide those two. So if you do second answer, or better yet, let's do alpha y equal second answer over 3.6 times 10 caret 6.
Don't say it.
I won't.
I got 2.24444 E -1.
Yes, ma'am. But let's change it out of scientific mode to normal mode to find out how much money it's going to cost us. $0.22.
Yeah, I was just about to say that.
Okay, 22 cents. Easy, right?
So the answer is 0.22.
Yes. Now, I am not going to go over the calometer one because I'm not expecting you to understand to get that. The only thing I want you to know about a calometer is a device that can measure a temperature change. Okay?
I wrote that in my flip book.
That's all I need to know. So now we've got all that done. Stop the video. So I told Jeffrey I would videotape.